Knowing how to put something together can help us understand how to take it apart later. In mathematics, we need to understand both so that we can do whatever a certain problem requires. In today's video, we are going to cover the rules for performing different operations with powers and radicals, from addition and subtraction to raising a power to a power. Before we get started, let's review the structure of terms containing radicals and powers. For radicals, we have the radical symbol, which looks like a check mark. Inside of that is the radicand. For powers, we start with the base. Both radicals and powers have indexes. In a radical, this is the superscript nested in the radical symbol. For powers, it is the value of the exponent. Finally, we have the coefficients, which are multipliers that show up in front of the radical or variable in question. Understanding the structural vocabulary of radicals and powers will allow us to describe the following operations more easily. Let's start with adding and subtracting powers. Consider the expression 2xy squared plus 13xy squared. We can factor this expression by reversing the distributive property. Looking at the two terms, they share a factor of xy squared, so we will factor this out. When we factor something out, we divide it out from the terms of the original expression and place it in front as a multiplier. The remaining portions of each term stay inside a set of parentheses. So 2xy squared plus 13xy squared becomes xy squared times the sum of 2 and 13. This simplifies to xy squared times 15, which, according to the commutative property, can be rewritten as 15xy squared. You could also do this for subtraction, given that the negative stays with its term inside the parentheses. Now, this process becomes simpler when we recognize that any time two terms have the same variables with the same associated exponents, all we need to do to combine them is add or subtract the coefficients. Now we can tackle multiplication and division of powers. Let's remember that powers tell us to multiply 1 by the base the number of times indicated by the exponent. So if we have x to the third power, that's 1 times x times x times x. Now say we multiply 7xy times 5x squared y. This could be rewritten as 7 times x times y times 5 times x times x times y. Using the commutative property, we can rearrange to get 7 times x times x times x times y times y. 7 times 5 gives us 35. When we brought together the two groups of x's, we got x times x, which is equal to x to the third. And bringing together the y's from each factor gave us y times y, which equals y squared. So the whole thing simplifies to 35 x to the third y squared. Essentially, we multiplied the coefficients and we added the exponents from matching bases in each factor. Multiplying powers required multiplication and addition. Dividing powers will require division and subtraction. Imagine we have 15x to the third m divided by 5xm. This could be rewritten as the product of 15x, x, and m over the product of 5x and m. We see that 15 and 5 divide to give us 3, while the x in the denominator removes one of the x's from the numerator by dividing it to equal 1. This leaves 2 x's, or x squared, in the numerator. Finally, the 1m in the numerator and the 1m in the denominator divide to 1, leaving us with no m in the final result, which will be 3x squared. Essentially, we divided the coefficients and subtracted the exponents from matching bases in the numerator and denominator. Let's look at what happens when we raise a power to a power. If I have 3x squared to the fourth, it can be rewritten as 3x squared times 3x squared times 3x squared times 3x squared. By our multiplication rule, we know that this equals 3 times 3 times 3 times 3 times x to the 2 plus 2 plus 2 plus 2 power. The repeated multiplication of 3 would give us 3 to the 4th, and the repeated addition in the exponent would give us an exponent of 4 times 2. This simplifies to 243x to the 8th. If we look closer, when we raise a power to a power, any included coefficient will be raised to the power outside the parentheses, while the inside power will be multiplied by the outside power. One way to remember the rules for powers is the step-down rule. If we think of operations as a staircase with exponents at the top, then multiplication and division, then addition and subtraction, then no change, the coefficients will abide by the original operation shown in the problem, while the exponents will follow the one that's a step down. Let's move on to radicals. When we add or subtract radicals, we follow the same rules as adding and subtracting powers. For example, given 7 times the third root of 5x minus the third root of 5x, we could subtract the coefficients, giving us the difference of 7 and 1 times the third root of 5x. This equals 6 times the third root of 5x. To multiply and divide radicals, both radicals still need to have the same index. Then we multiply or divide coefficient by coefficient and radicand by radicand. Each element will stay in place. For example, 3 times the square root of 2 times 4 times the square root of 5 is equal to 3 times 4 times the square root of the product of 2 and 5. This equals 12 times the square root of 10. In division, 8 square root of 14 divided by 2 square root of 7 equals 8 divided by 2 times the square root of the quotient of 14 and 7. It will end up equaling 4 square root of 2. By mastering these rules, you can use them to rewrite expressions in the forms most useful to you. It will also help when simplifying expressions. In this video, we covered rules for operations with radicals and powers.